Good morning, guys. It's Navi Jonathan. Can you guys hear me? Could you please type in chat window? Great. Thank you, guys. Give me one moment here. Sharing the screen. Okay. Okay. So yesterday we discussed a little bit about the scalar, some of the functions and few of the match and the case operations and things like that. Let's dig a little bit deep into some of the other operations and things like that, guys. Okay. I need one of you guys to come online, and I need you guys to get into the scalar on the web shell, please. Can one of you come online and any volunteers there? How about, let's say, both of the Ganesh didn't turn up yesterday. Nasham, Navya, okay, Harshita. How about Jyotsna, Amulya, any one of you? Can you come online and bring up the web shell, please? Let's see, Jyotsna or Amulya. I think Lokesh, yesterday you were there. How about Dhanushvi? How about Praharsha? Pratyusha, I think you already did it. Praharsha. How about Priyusha? Anybody logged into the web shell? Rahul or Bhuvaneshwari? The next two. Revati is or Sai Srirupa. Anybody? And let's say Divya or Shebas. Shebas, okay. Go ahead and share your screen, buddy. Okay, Shebas, you just log into the web shell. Let me cover a little bit of theory and come back to you. Can you hear me, Shebas?
Oh, yes, Navin, I can hear you.
You just keep logging in while I cover a little bit of theory.
Yeah,
So,
okay.
clearly defines a rich set of collections, retrieval sets of elements. These are some of the things that we have looked at in Python. They are similar to Python, guys. Okay. So let's say list is a linked list of elements of the same type. So here, list is a list of elements of the same type. It is acting like an array, a tray of similar cups, guys. Okay. Set of pairwise different elements. Each element can be contained only once. Again, it is same as set in Python. If you recall, set is a tray in which you can have unique items, or in other words, there are no duplicate items. Map is a collection of key value pairs. So in other words, map is nothing but dictionary in Python, a group of keys and values. And we'll talk a little bit about, okay? So tuple is a collection of objects of various types. In other words, here, tuple is acting like a list in Python. It is a group of objects of different types. Option, okay, options 0 or 1 element. So we'll see what is option. It's like an enumeration. And range is a collection of values. Range is a group of values which are consecutive values, or maybe a step of values and things like that. So let's dig into each one of them. So here is scalar maps. Maps is nothing but a dictionary. A map is a collection of pair. Pair is nothing but key and a value. A pair is a group of two values. They need not be of same type. You can have anything. So short and sweet, map is a dictionary. Just like we create a dictionary object, we're creating a map object, guys. Okay. And let's see. Accessing maps, again, if in a dictionary, if you want to access value, we use the key. Here also, we are using the key to access value. So Vishal is the key. And let's say if we scroll back a little bit, for Vishal, Kumar is the value. Next, Vijay is the key, Verma is the value. So if you say mapping of Vishal, what is mapping? Mapping is an object. It's like saying dictionary of that key, will get the value. Now notice here, mapping dot get or else of Vish. In other words, what this does is, it is looking to see if there is a key called Vish. We do have Vishal, we don't have Vish. So what will happen? Get or else is, it is going to return a 0 if the key is not found. Everybody with me, guys, quickest please. Cool. Okay, so iterating maps, again, we've seen how to, if we have a dictionary, we iterate the dictionary using a key and a value. That's what we'll try to spend a little time and try to understand that one. Next comes the scalar tuples. Tuple is a more generalized form of a pair. Generalized means very general. It can have anything. Tuple has more than 2 values of potentially different types. So in other words, it's acting like a list object. It has the syntax of the tuple in Python, but it is acting like a list object in Python. So notice 1, 4, Bob and Jack, that is 2 teacups and 2 coffee cups. How do you access elements? We are using a dot underscore. We can use a normal bracket or a space underscore also can be used. That's a kind of a trick in scalar. In tuples, the offset starts with 1, which means they are 1 based index. Tuples are following 1 based index, not 0 based index. Tuples are typically used for the functions which return more than 1 value. Now, this is a slightly tougher one. New Delhi, India dot partition dot underscore upper. What it does is, it is going to choose N, it is going to choose D, and then it is going to choose I. In other words, it's going to go over each character. It will check if it is upper, and then it will return it. In other words, that's like 1 or 2 nested for loops if we were to write in a Java or .NET, is what it is, guys. Okay. And again, we'll try to execute that. It will become much more easier for us to understand when we execute it, guys. Next comes list, ordered immutable list of elements. So these are immutable. These are acting like tuples. Elements cannot be changed. So basic list operations, list, head, tail, is, empty, size. These are the common operations. So there it is. We're creating a list of 1, 2. List.head equals to 1. And list.tail equals to list of 2. So list is either nil or a combination of head and tail elements. Okay, so in other words, more precisely, the head will be 1. The first one will be 1. Whatever is on the right hand side will become the tail here. Again, we'll execute this, guys. It becomes more easier for us to understand it when we are writing the code. Now here's a slightly complex one. We can use iterator to iterate over a list, but recursion is preferred practice in scalar. Do any of you know what is the meaning of recursion, guys? Slightly tough question. What is recursion? Calling itself, calling the same function inside the same inside the function. It will be recursively, it might go many times unless we don't have the proper logic. So again, I'll leave that example when we discuss about it. So let's see what we have. A is a list of 1, 2, 3. B is a nil. Nil means just nothing, it's like a none or a null. C is an empty list object. Now notice D. D, 0 double colon A. What is the double colon? It is appending. Just like we have extend in Python, that is what the double colon is. 0 double colon A has become 0, 1, 2, 3. 0 double colon B. So it is kind of extending it. Nil and list are both empty lists. So when B and C are empty lists is what we are saying. A double colon B returns a new list with A as the first item and the remaining part B called the tail. That we'll try to understand, guys. Okay. Then we'll briefly look at the pattern matching. Function A of list, A match, case list. So this is where a little bit of tuple unpacking is going on, if you recall. And Pattern matching helps you pull apart complex data structures and analyze their components in an elegant way. You're pulling the complex data structures. The case is here a list object of 0, P, and Q. That's a tray of 3 cups. Now, this is a slightly deep one, guys, okay? And what is P plus Q? Whatever the case matches, that will be returned. Remember, if you recall in Scala, it will not explicitly say return. It is generally executing the last line. What do you think is underscore, guys? Case underscore means? Anybody? Do you recall what is case underscore? It is default. If none of the patterns match, then the default is getting executed. We'll see that. Again, another list here. The compiler warns us when it detects that match is not exhausted. Okay, generally when you don't give a default, it is giving you a warning, a friendly warning. Warning is always a friendly warning, indicating that, hey, there are other scenarios which might get executed. There are other permutations and combinations which might get executed. You don't have your code given there. The code is not given in the code, is what that refers to, guys, okay? Then again, def length, a match, again, h colon tail. Okay, we are yet to see this. A simple recursive routine for computing length of list. If list is empty, length is 0, otherwise it is 1 plus length of the remaining part. Again, I will try to give attention to it when we do it in the lab. And Shebas, are you logged in to the lab?
Yes, Naveen.
Go ahead and share your screen, please. Okay, I'll be sending it step by step and I try to execute it. Let's see, start with the first one. Close this one. Full screen. Chat window. Okay. Execute this, please. I will say quick sort after that. I think you need to right click it and say paste from browser so that you don't have any special characters coming up. Good. What is an array, Shebas?
Array is a list of elements, Naveen.
A tray of?
Unordered elements.
Similar elements.
Similar.
Same. Okay. Okay. Do the quick sort, please. No, I sent you, buddy. You can type it if you're not able to.
It's done, Naveen.
Okay. 1, 2, 4, 3 is transformed to 1, 2, 3, 4. That is an example of a quick sort. But let's see what else we have. Okay, here comes a slightly deep one. Okay, run this, please. Hard. Now here's a slightly tough one, Shivas. Can you take a guess what it is? What's happening here?
The first letters of each word is separated by another object in the eye.
Good answer. So what do you think is the first step it is doing? Uppercase would be the second step, guys. What do you think is the first case? The first step is partition, means it's separating the parts. What are parts here? Tough question. It is splitting, separating the new, separating the Delhi, separating the India into three parts. And then, okay, notice there is an underscore. Now in Scala, the underscore is the first one. So in other words, let me share my screen here for a moment. So bring up this one. Here we go. What this one? Snap it. This here. This here. Back here. Share the screen. So yes, here we go. So if you're looking at this, guys, think of this. New Delhi, India is one cup, one coffee cup. When you say partition, what it is doing is, it is taking New Delhi, India, it's creating a tray. It's separating that into, start with this one. New is going to be separated. It's splitting new. Then let's say Delhi. Then let's say India. Oops. India. New Delhi, India is what it is separating. Now what it is doing is, in new, it is picking up the first letter. And then it is checking, is it upper? If it is upper, what it is doing is, it is going to take that one, it's going to put it here. Visualize the new cup here. Then it picks up Delhi. In Delhi, it is going to pick up D, capital D. The rest of the characters in Delhi are not capitals. Then it goes to India, picks up I. And now the remaining, so when it picked up new, N it has put this side, but visualize EW is being, in other words, EW. So N is, after it puts N here, EW is being put here, then it is separating. Then the next one is Delhi, capital D. So come here, here's ELHI. So ELHI will come up to here, and then a space, and then comes India. So let's say N T. So what is it doing? It has created two parts. These two are inside a tuple. That is a tuple. There are two coffee cups. One is the pink one, other one is the blue one. And what did it do? It partitioned it. It created one object has been partitioned into two objects. Here we have given is upper is maybe a simple function. But in a real world, we may have complex requirements or complex logic written. Based on our requirement, we may write customized logic and pass our own function here. Everybody catching it, guys? Quick yes, please. Shabaz, are you catching it? Okay, another thing to be aware in the world of Scala is, by default, when it says underscore, you see that if you notice that's an underscore dot. What is that underscore doing is, imagine here is new, N, E, oops, E, let's say W. That underscore refers to each character each item inside the coffee cup. So ideally, this green cup, okay, behind the scenes, what it is doing is it is creating a tray out of that cup. And then it's putting 3 cups inside. So now N, capital N is here, E and W. So what is this one? This tray is actually inside that tray. Kind of visualize like that. Or this cup has been modified into the tray. Now the underscore is going to become N. The underscore here is going to become N. Then it will go to the next one. Next it will become E. And what's happening? Each character is being checked and seen if it is upper or not. So in other words, it is just a 1 line of code, but there's a 10 lines of story associated with it, with that particular function. What is that? That is patternized code. That is what is special about Scala. This is also referred as high level, very high level. Python itself is a high level language. Okay, Scala is also sitting as a very high level language there. Everybody catching it, guys? Guys, Shebas, are you catching it, buddy?
Yes, none.
So underscore is one thing to understand. Is upper is one thing to understand. The output, how it created a tuple of 2 coffee cups is another thing to understand. Each one 2 to 3 lines, that's close to maybe 10 lines of a story going on there, guys. Okay, let's say, okay, back to share your screen, Shivas. Now change is upper to is lower after you share it. Okay, as simple as that. Press enter. Catching it, Shebas?
Oh, yes, none.
So each of the characters which are lower have been separated and put on the left-hand side. The remaining things are, it is storing it on the right-hand side. The left-hand side part of it is generally referred as the head. Okay, and let's see what else we have. Come back here. Okay, let's execute this one. Here is value list. Here is the next one, Shebas. So go to the chat window. And just type in list.head after that, after you type it in. Type in list.head. No, the object list, LST. Okay, notice where we're getting a 1. Type in tail. Okay, notice we're getting a list of 2. Notice when you say head, it was giving you a teacup. But when you say tail, it is giving you a tray of a single teacup. Create another list object, let's say 1, 2, 3, 4, 5. Okay, now list one.head. And notice we should get a teacup. And now do a list one.tail. So what is special, guys? When you say tail, except for the first one, the remaining things it is putting in the tail. It is more of a link from a computer science standpoint. It is nothing but a linked list concept. Will not go into the technical details. It's not necessary. But for now, you just remember tail means it's giving you a tray of the remaining items. Because it's a group of items, it's giving us as a tray, not as individual elements. Shiva's catching it, buddy.
Oh, yes, none.
Let's say 1, 2, 3, head and tail. Okay. Now let's say 2 double colon.
List of none.
Yeah, you can just create. No. 2, element number 2. 2 double colon. Just a list of 1, 2. Oops, no man. 2 double colon, by the side of it, say list, capital L, list 3, 4.
List of 2, 3, 4.
List of 3, 4.
They run this now.
Yeah. So notice it has given a list of 2, 2, 3, 4. The left hand side has become the head. So res 8, result 8 dot head you do. Result, res 8. Res 8, buddy.
Oops, okay.
So there is res 8. Now do a res 8 of 2. Res 8 dot head. Notice we get to 2 and do a tail.
Yeah.
You get 2, 3, 4. Whatever was plugged in on the right hand side, whatever is remaining on the right hand side. Everybody catching it, guys? Quick yes, please. So the characteristic of a list in Scala is it has a head and a tail, something which explicitly keep in mind. Everybody doing okay, guys? Okay, see. Back to chat. Okay, run this one, please. You can run them on multiple lines. So take a look at D. So sorry, what did we do? Yeah, take a look at D. Just type in D. Okay, notice D is 0, 1, 2, 3. And what's happening here? The head and tail are being 0. Has become the head and double colon. This is nothing but extend in Python, if you recall. Do you recall, Shabazz?
Yes, Naveen.
Okay. Everybody else okay with this one, guys? Quick yes, please. Okay. So I come back here. Try another one. That equals to 0 double colon B. Try this one. Take a look at E. Oh, pardon me. So now there is something going on here, Shabazz. Can you take a guess what is going on in E, object E? That's a slightly deep one.
0 is storing inside B, Naveen. Object B list, which is empty.
0 is okay, list is empty. Okay, in other words, nil is an empty list. 0 is a tray. If you say add a teacup to a tray, that's becoming a tray of 1 cup. So that's why we have list of 0. Now say E dot head. Should get 0. Say E dot tail.
Empty list.
Good answer. So in other words, there is not much tail. There is no tail here. There's only head here. Catching it, Shavas?
Yes, Naveen.
Okay. A moment. Okay, slightly deep one. So run this one. Oops, one more time. Run this one, please. You can use colon paste, right?
Can I call a function, Naveen?
Oh, okay. You already did that. Okay. Continue. Okay, keep working on that. Give me a moment here, Shavas. I'll be right back.
Yeah, okay, Naveen.
Okay. So let's see. Did you get it? What do you think is going on, Shivas?
Oh, yes, Naveen.
What are we doing here?
Here we are passing 3 arguments. If you pass 3 arguments, the other 2 arguments are getting added and result in printing.
What do you think the function is actually doing? It's a slightly tough one.
The element which we pass is checking whether it's matching inside the cases or not.
If you pass one argument, what is happening?
It's printing default case.
2?
2 is also printing default case.
Show me.
Oh, yeah.
Yeah. Now let's say pass list of 1, 2, 3. Why?
It's the list element should start with 0. Then only the case 1 will get printed.
Very good. So the pattern we are looking for is it is looking for a pattern which is a tray which is starting with a 0, right? So what is P and Q?
P and Q are the second index and third index inside function arguments.
Very good. Second index and the third index are simple as that. Let's say I come back here. So we pass 3. Okay, try to pass 4 arguments, four cups. Okay.
It's default case.
Good. So let's try another one. Okay, run this please.
I mean, this one was the previous one, right?
Sorry. One more time. What did you say?
Previously, we executed this, Naveen.
It's different.
This is a slightly different one. There's a subtle difference. That's what my question was.
Okay, the default case.
Okay. So are you catching it?
Yes, Naveen.
What is the problem?
Here there is no default case. I mean, that's why it's printing error.
Try to pass in an empty list. Are you catching it?
Yes, Naveen.
Yeah. So when you pass in an empty list, it's kind of acting like the last case which is matching. These are the different kinds of patterns. Now let's say here's a slightly deep one. See if you can execute this. So let's say, so can you take a guess what is different here? Shebas. If you look at the function, there is something different going on here.
The size of the list getting added with 1. So that's why it's printing 3.
So what do you think is H and P?
Head and tail.
Good answer. And let's see. If you want to look at the head, or in other words, let me ask you like this. How do you think it is? It is saying this is the head and this is the tail. How do you think it knows what is the head and what is the tail?
Head is the first element of a tray. Remaining all the tray consider as tail.
Good answer. So when you're passing list of 1 to 3, what's happening?
First, here one is considered as head and 2 and 3 are tail.
Good answer. One is becoming the head, 2 and 3 are becoming the tail. So what is H double colon T?
Double colon T. And this slicing.
That is nothing but the syntax of a list object. That's another way we're creating a list object. Let's say type in 1 double colon of 2 comma 3. Enter. Okay. Tough question. Why do you think it is not working? Okay, any Very good, Lavanya, keep it up. Okay, so that is what is kind of, we'll look at another perspective of this one. Let's say, okay, here is another one. Increasing the complexity from this place. Okay, what do you think is going on now?
A is greater than B, then it's printing 0 again, or else it's getting added up. Those two, A and B, are getting added up.
What do we call this function?
And here we are also calling function again, so it's recursion.
Recursion. That's an example of recursion. So what do you think when you're recursing, why are we adding a 1 to it?
The steps could decrease in next.
Try something like 1 and 5. So what do you think is happening?
In first step, 1 plus 1 is getting. Next, a becomes 2, 2 plus 1. Next, it's 3, 3 plus 1. Like that, it's going till 5.
So what is the meaning of that, Shabazz? Don't think it is Fibonacci, Lavanya. This is a much more simple one.
Sum of integers, whatever is present between 1 to 5.
Good. So it is recursively adding the numbers. Between 1 and 5, it's taking all the numbers, it's summing all the numbers between 1, the first argument and the last argument. But let's say you give 5 and 1.
Giving 0 knowing.
Okay. Now let's say, okay, what is meaning of 0?
Yeah, we have written logic as if a is greater than p, then print 0. So that's why we are getting 0 here.
Okay, can you try to modify the function in such a way where the 5 and 1 will also give you similar results? That's a tough one.
Oh, we should change if a is less than b.
Oh, write it, change the function, don't tell it. Shabazz, can you hear me, buddy?
Oh, yes, Navin, I can hear you.
Hello, Shabazz, guys, can you hear me? Could you please type in the chat window?
Yes, Navin, I can hear you.
Okay, sorry about that. Okay, so let's say, paste it and show me what you have. I'll give you a hint. If A is greater than B, you need to make the change there.
That's what I was seeing.
Mhm. I think what you need to do is, if A is greater than B, then you say A plus A plus summons of A minus 1 comma B. Okay, copy that whole line. Catching it, what's happening? We're getting at 25, huh?
Yeah, now we got 15. I mean.
And what was change you did? If A is less than B, you're doing 0, else you're doing, oh, very nice. Good one there. Okay. And let's see. Mess up. Okay. Maybe a simple one. Let's try this one, shows. So what do you think is going on?
Varying.
As simple as that. Okay. Let's see if you can catch this one. Oops. Okay. Hmm. Oh. Okay. You have any idea what is going on there? Shabas, any idea what is going on, Mary?
There is a limit for those integer inside memory, Naveen.
Right, but what is the function doing?
Function is it's giving powers of 2, Naveen.
Ah, good answer. Okay. Okay, increasing the complexity. So I come back here. Okay. See if you can try power 31. So the bits and bytes are coming into the picture. That's what is happening. Let's say try this function. Any idea what is happening?
The values are getting incremented now. +1 by +1.
So in other words, we pass 2 arguments, we're just adding a 1 to each one, and then what is happening? Simple answer you're missing.
Matching.
It is returning a tuple. Okay.
Okay.
So let's see. Back here. Back up here. We've just looked at the increment, okay? So, okay. Slightly confusing one, but let's see. Okay, run this please. Matching case, we've already looked at it. Still getting problem?
Yes, no.
Okay. Looking at square function list. The foo, okay. So if you look at it, it says error not found, foo. What is foo?
Function.
What is bar?
Bar is also a function, but they didn't define it.
That is why it is giving you a problem.
Yeah.
Try to define just a function called bar and then try to run the foo.
Yeah, okay. No.
You can just say print line something, print line bar or something like that. Print line of bar. Huh? Bar should be in quotes, right? And I think the flower brackets are missing on there. Slide I need to get in there. Just writing another function for you. So others feel free to give some hints to. So 1, 2, 3. Python list. Numbers only. Seeing these things. Adding elements. Okay. Come up here. Bar and bar. Okay. When you look at unit, what does it? What do you think is unit, Shabas?
Unit return output.
Unit is? Unit is nil or none or none, null or nothing or void in Scala. Okay.
Okay, nice.
Okay, let's see. Move on to the next one. Okay, there are two things I just sent you. What do you think that is doing?
It's giving like a index number 1.
In other words, short and sweet, it's following a zero-based index and it's extracting the second element, as simple as that, okay?
Yes, sir.
Okay, slice it. Slice it. What do you think that is doing?
It's starting from 0 index till 3rd index, and 3rd index is not included.
Good. So in other words, if you recall the inclusive versus the exclusive mantra, okay?
Yes, sir.
In Python, what would we do?
We use instead of comma like colon.
Good. And what do you use for slice? What do you think you'll use for the dot slice? It's just a bracket, square bracket, okay?
Oh, yes, no.
Okay, let's say I will save the map here. Map is a slightly deep one. Let's try this one. Let's see. No, I have one more thing. Okay, let's see if you can run this, please. Pardon me. Sorry about that. What do you do? What do you think is happening?
Oh, printing the elements.
Okay, so what is different here when you compare it to Python?
Condition.
In other words, if you look at the syntax, in Python will say for I in my array. Here we are giving the less than and hyphen. Are you catching it, Shabazz?
Oh, yes, no.
That is the change. And again in Python, we have the indentation, we have the tab, we have the colon. Whereas here it is following a flower bracket, as simple as that, okay?
Okay.
Here's a slightly tough one. Let's see if you're able to recall this one. And let's see if I can help you in this one. Zoom meeting, here we go, paste it, okay. Run this plus. Okay. I'll try this one. Copy this one. And okay, how about this one? Since we are running into these issues, exit out of the scalar shell. Just say vi test.scalar. And copy paste the code I have sent you. Do you have everything correct? I think it should start with exclamation. I'm sorry, hash exclamation. You don't need the first line.
Oh, yes.
Hash exclamation bin as such. How come it put like that?
Oh, now I have pasted now.
Scalar. Okay, you have it as test.scalar. Okay, and I think you can remove the second and the third line. So sorry, only second line. So in other words, you should have the bin as such in the first line. That is okay. The second one, exec scalar. And we're saying args.next string. So, next string. Did you? Exec scalar. Okay. I'll copy paste one more time what I sent you.
Yeah, okay. Man.
Okay, how about this one? Let's say much more shortcut here. Paste it here. I'm sending another one. Instead of having multiple lines, this is probably a much more simple one. Okay, try this one. Delete the complete all the lines. You can say escape dd, it will delete one line. Delete all the lines and paste this one.
One minute now.
Yeah. Did you do an escape append? Okay. Looks good. Save it. Escape shift colon WQ. Now say ls. Oh, ls-ltr. Test.scalar. Okay, now say /test.scalar. Permission. What is that? chmod +x space +x space test.scalar. Okay. Now just say /test.scalar. Okay. Warning. One warning found. Hello. Okay. Now say /test.scalar space mera space bharat space mahan.
Should use quotes.
No. Bharat Mahan is enough. Good. Those are 3 arguments.
Should I run this, Naveen?
Yeah. So hello, Mera Bharat Mahan. So what is happening is now we can put our complex scripts inside that scalar file and we can just run it like that. So go back to VI, let's say open another one. Let's say VI space test2.scalar. Oh, if it is inside this function, we need to call this function. Oh, okay. So in other words, if I go back here, there'll be another challenge, right? Okay. So what we'll do, we'll try something here. Okay, sending you some data. So copy this one, come back here, paste it here. And here, here's this one. Okay, what quit out of this file. Let's save a new file called data.txt or data.csv and paste this one into the quit out of the file, say vi data.txt and save this data. Let's come with the step. Then the second step, what we'll do. Oh, we're getting into the world of Spark here. Just give a quick try here. VIR text run. Where are you? Okay, just save it as, I think the first one is employee ID, right?
Employee number, Naveen.
Yeah. Employee number. Just put employee number there. And you did a care table. Is there a empty line on the top?
Oh yes, I think
Remove that empty line. Oops, what did you do? Did you delete everything?
1 minute. Naveen. Actually, the above line is I think it's like inbuilt one. I mean, not able to remove that line.
You're not able to scroll up now?
Yeah. No, I can scroll up, but it's not. I'm not able to give a backspace.
No. Do an escape. Scroll up.
1 minute.
Just the up arrow. Or escape J. Escape DD. Now
Okay. No, I can.
Scalar, right? Next, say vi rtf.scalar. And let's see, try to place this one. I think you need to escape I and say I. Now I think you can leave it like that. You don't need to worry about the indentation. Write and quit it. And now get into the scalar shell. Now let's say try this one. Use here's this one. Use small letters. So I'll change that RTF. Okay. In the scalar shell, do that. Load the RTF.scalar. :load. Let's see. Oh, okay. Because this is on the Spark. Just type in Spark. Oh, no. Quit out of Scala, exit out of Scala. Spark-shell. Give it a moment. Okay. Now say colon load rtf.scalar. Okay. Now let's say come back here. Say rtf.main like this. So our class file, what did we define a class file? Was it RTF or read text file? Scroll up, please. If you look at the class file that we pasted, scroll up. Do we have it? Oh, just say cat rtf.scalar. Yes.
I think we need to go outside Scala and
no, it's defined. It's read text file. So do this one. I'm sending this one. So instead of RTF, I think we need to have read text file here. Let me come back here, copy this one. So here is read text file. Copy this one. Paste it here. Try this one, please. There you go. Double quotes. It's double quotes. And let's see, so it is okay. It's looking in the HDFS mode, the data.txt. So what you do, big data user trouble, user slash big data. So type in Hadoop FS put, Hadoop space FS hyphen put, Hadoop space FS space hyphen put.
Oh, it's lagging now. I've been typing, but it's lagging.
There's a delay?
Yeah.
I think what we can do is we'll give it manually. Let me see how I can do that. File colon. So what you do, read text file. Bring up the previous command. So say file colon. No. In the data.txt, before the data.txt, you'll say file colon. No, inside the quotes.
Okay.
Here. File colon. Say slash home slash big data user 112. That's your username, right?
Yes.
File colon 3 forward slash. 3 times forward slash. colon 3 / say home / big. I think I need the one / data.txt. / man, not backslash.
Okay.
3. Rest of them 1 / okay, try it now. Big, bid, no, you gave it as big. BIG. So, okay, try it now. Cool. So it's reading it, it's processing it, let's say. So behind the scenes, it's running Spark, and I'll explain you what that means. Oh, it's slow. I think they have very limited resources here. Still on. Still running. Should be. Let's see what we do. Okay. Give a much more simple example. What we call this http.scalar. paste this one. Still running. Just do Control C, Control C, Control Z, Control V. Put it okay. Okay, we are now in scalar shell, right? We are quit out of the scalar shell. Say VIH W dot scalar. And paste code. Paste it, right? Now let's say, I think what I'm doing is, we'll just say, I need to get into scalar mode. Hello world dot main. So cat hello world dot scalar, HW dot scalar. You can just do it. Okay, so just give it to the hello world. We need to just say, give the execute permission, which is chmod plus x HW dot scalar. Dot slash HW dot scalar. Syntax error. Case class person name string object hello world. Dot slash. Saying syntax error. It's not. Oh, what is it saying? What you're trying to do? Just say scalar space HW dot scalar. Person. Okay. So that's a simple example of how we can run it. Now go back, open that file. BIHW dot scalar. At the end, in the last line, put this one. After the last line. Now what do you do? Scalar strip has main object, but statement is disallowed. One warning found. Okay, that's a warning. That's okay. So now go back to hw.scalar. Reopen that file. We have a case class hello and object hello world.main. So we're calling hello world.main. Try to add another function. Let us say hello inside that object hello world. Inside the def, just like we have def main, right? Add another function called def hello and just say print line hello. You need to add it in the after the next flower bracket. No, not there. After the next flower bracket here. Give a little bit of spacing and then within quotes. Did you close the flower bracket? You need to give another flower bracket to close that. Hello. Escape now. Let's do an escape append.
Here it is there now in flower bracket.
But the flower bracket for hello world is missing. So add another line after that flower bracket. And now put a close bracket. Now save it. Oh, no, wait. I'm not yet done. So we do have a hello. Now go back to the main function. After print line of AL in the next line, say AL.hello. Print line of AL.hello. Or just say AL.hello. Oh, no. AL is a person object. Just say hello.
Println.
Just hello. Hello will print it.
Set quotes, Ravi.
No. Hello in because this scale. Okay, that should be okay because there are no arguments here. Now write and quit it. Now say scalar hw.scalar. Hello, welcome is getting printed. Okay. So what we're doing is, so now say cp hw.scalar. cp space hw.scalar space hw2.scalar. Now get back into say vi hw2.scalar. Remove the case class, that line. The first case class, first line, escape dd. And remove the AL person, val AL. The third line, the fourth line, remove the third and the fourth line. Okay, write and quit. Now run that. This will be hw2.scalar. Okay, hello, welcome. So we are successfully calling the function. Now I'll give you a slightly complex function. We'll have to go back to that file and let's try to add this one. Okay, try to add this function to that file.
At the end, Naveen.
Yeah, after hello, add it. After the hello function, yeah. Have you tried Control-Shift-V? I think that should also work. Okay. So we added the variable number of args, int equal to variable and args of args. Okay. Now go back to the main function after print line of hello. Say Variables arguments.
Naveen,
Give the name of that. Variables arguments.
should I print?
Yeah, type it. The name of the function, variables arguments. And within that, give a list of 1, 2, 3. Okay. Write and quit, execute it. So one morning, and let's say error type mismatch. So list of 1, 2, 3. We are giving it a list of 1, 2, 3, right? So go back to HW2. So it's what we are looking at is star args. What we looked at in Python star args is what this one is, guys. Okay. Don't give list. Change the remove the list and just say 1, 2, 3. Remove the tuple also. Okay. Now write and quit. Cool. So we got hello, welcome, and what we are getting. So what we'll do, back to our thing. HW2, and here in variable arguments, what we're doing is, after we're done, we just set n at the end. So that should be returned automatically. N plus equal to args. We didn't print anything. That's strange. Below, where you have n and the last third line or fourth line, after that n, or on top of that n, print n, say print line of n. Or no. Let's take a shortcut. Go back to the main function. In variables arguments, just say print line of variables arguments. Say print line of variables arguments. Escape and no. On the above line. In the top line, where it says variable arguments, just add a print line of variables for arguments. Print line. Close bracket. Okay, run it now. Six. Okay. So 1 plus 2 plus 3 is 6. Now, when you look at the function, do you think you understand that, Shivas? This is slightly deeper.
Oh, yeah.
1 second. Okay. So, any idea what is going on here? Okay, go back to the file, add another line below that print line. This time give 1, 2, 3, 4.
Should I modify that line or add another new line?
Add a new line. And guys, let's do this. Let's take a break here. Let's regroup by 2 and continue from here, Shabazz. Okay?
Yeah, okay, now.
Thank you. Okay. Shabazz, are you back, buddy?
Yes, Naveen.
Can you share your screen? Can you show us where we were? Okay. So what do you think is variable arguments about, guys? Shabazz.
It means a number of arguments we can pass as per our requirements.
Good. Let's see. Okay. Go to the next one. Okay, let's see. Add this function inside the same file, Shabazz.
Yeah, okay, Naveen. Now, where should I add this function, Naveen?
Just after we, just on top of hello, between main and hello.
Yeah, okay. Yeah, Naveen.
You can
Hello.
run. Can you cat it? Okay. So you added the default. Are you calling it anywhere?
No, Naveen. I have to call.
Yeah. After the print line variable args.
Naveen, here one is already defined default arguments. Should I call once again?
Yeah. Give multiple combinations there, please. Add another default also.
Yeah.
Looks like you're missing a bracket there.
Okay. Warning. Error we are getting.
Sorry, I was on mute. Warning is okay, but error is not okay. Got it? Huh? So what is default doing? Oh, sorry. Have you run it?
I already run it.
So what do you think it is doing?
It's multiplying two arguments now.
What is default?
Default is a function again. We have defined it.
Okay. What is special about the argument? Do you see anything different about the arguments?
Here some are, already defined inside a function. And other one is we have to call during function. We have to define during function call. Default and positional arguments.
In other words, the argument values are hard-coded.
Yeah.
Right?
Yes.
Okay. I have sent you two more defaults. Go ahead and add them in the main.
We are getting error now.
No. What do you do? Think, yeah?
Oh, ups, 1 minute, 1 minute. I forgot to.
I think it is complaining about the default underscore, right?
Yes, Naveen.
And we actually have one value x is hard coded, y is not hard coded. So y must always be given. X is the default value. So actually, the underscore should leave it as it is. It should really declare x equal to 1 if the underscore is there. Can you run it one more time, please? Missing parameter type. $score y should be mapped to 3 and x should be mapped. So it's not taking underscore, strange. Interesting. Maybe I don't know why it's being taken. Okay. It's okay. You can comment that, just use 2//
Okay, Naveen.
and let me share my screen for a moment here again. Okay. Can you see my screen?
No, Naveen, it's black screen. I can see.
One moment. How about now?
Oh, no, I can see.
You've seen the slide, right? Full slide, right?
Yes, Naveen.
Okay. So again, we have already looked at the functions. So group of statements. We invoke a function, we call the function. When function that returns no result is unit. It's called a procedure. So that is something to be aware of, guys. Okay, function that is not returning everything is referred as procedure. And let's see what we have. They can be passed as a parameter. They can be passed as a result. Functions in scalar first-class values. In other words, just like in Python, the functions are also first-class citizens or first-class values means they are like objects. Functions which use a function as a parameter or as a result is a higher order function. So this is slightly an advanced concept, guys. Higher order functions. Functions always result in a value. We'll try to understand and simplify what is a higher order function. The final line of a function becomes result. A little bit of theory there. Operators in scale are actually in fixed notation calls to function. So in other words, if you notice here, my object.foo, foo of 42 can also be called like this. My object foo 42. It can also be called plus function. So you can also use a plus function with argument 42. Okay. A little bit of academic importance. Okay. But let's see. Higher order functions. Functional languages treat functions as first class values, means the functions are treated as objects. Objects are the first class units. A function can be treated as an object. This means that like any other value, a function can be passed as a parameter and returned as a result, which means we will see this. It will probably be more simple or more understandable if you look at the code, but let me explain it first. Try to explain this one first. We are saying a function can be passed as a parameter. Until now, we have been passing teacups and coffee cups as the arguments. But now we are saying we can also pass the code as an argument. What is function? Function is nothing but a code. Not only can we pass the code as argument, we can also return the result. What a function returns can also be code or a function. What is that? That is the concept of higher order functions. This provides a flexible way to compose programs. In other words, in the world of big data and things like that, most of the time we come across these scenarios, guys. Okay. Functions that take other functions as parameters or that returns functions as results are called higher order functions. So a function which takes a function as an argument or returns a function object out of it is called as a higher function or a higher order function. We'll see why it is important. So take a look at this, back to summons. The summons is the one we have seen today. It is nothing but a recursive function, as simple as that, guys. Next, we have the cube, and now notice the cube. If you take a look at the cube, all it is doing is, you give any argument x, it is multiplying it with the same type. So kind of cubing it. And sum of cubes. Sum of cubes, again, notice, is a recursive function. Okay, we'll also try to execute that and see. And so now here comes, guys, here comes a little bit of complexity. Take a look at the first function sum. If you take a look at this function sum, I'm going to stop the share here for one moment. Back to sketch, put this here. Oh, it's not this one. Sketch it. Okay, so let's see what we have. So here is sum, guys. If you notice this one, notice this one. This is nothing but a single line function, which is like a lambda function. What is this one? This is the first argument to this function. So what is sum? Sum is a function. Sum is a function which is taking another function as an argument.
Navin's screen is not visible.
Oh, sorry, my bad. Here we go. Okay, let me undo this one. So take a look at this, guys. Here is sum is a function. And the first argument, if you notice, is nothing but a code. What is this one? A code. This is a function without a name. It is nothing but a lambda function. So what is happening is a lambda function is being given as an argument to this function. So what is sum? Sum is a function which is taking another function as an argument. What is that? That's a higher order function. Catching it, Shabazz?
Excellent.
Okay, so that's a slightly, let's see, let me adjust the screen here. Okay, now what it is doing is, it is again just doing the traditional stuff. Notice, it is checking if A is greater than B, it returns a 0, else f of A, then notice sum. So what is this f here? F is again that function which was sent as an argument. That argument is again being passed in a recursive way to the same function. So again, at the first look, that's a slightly maybe a difficult one, but we'll try to run and simplify it, guys. Okay. Now let's take another example before we go there. Here is summons. What summons is doing is, summons is now just calling the sum, this higher order function. And what is happening here is the function called id. If you look at this function called id, here is id. What id is doing is, it takes an argument, it just returns that argument. That's all. So what is id? id is a function. And what's happening? The function is being passed as an argument to sum. So what is sum? Sum is a higher order function. Next, take a look at cube. You give any argument, it's doing a kind of raising it to the power of 3. And let's say that is cube. And then fact is factorial. So let's see, we don't have factorials. Else factorial. So we need to write fact is if x equals 0, it will return 1, else fact of x minus 1. So that is ending up returning a factorial is what it is again. So what is happening is, summons, notice, it is calling, summons is calling sum cubes is calling sum factorials is also calling sum. A and B are the arguments given, but when they are calling sum, what is happening is they are passing a different argument. Here one is passing id, another one is passing cube, another one is passing factorial. So they're all calling the sum. So summons, sum cubes, sum factorials, we can say they are acting like wrappers. Internally, they are calling some and passing different functions. What is this? This is a slightly advanced way of calling the functions. Okay, but let me see, come back here. Okay, so these are again examples. So Shabazz, bring up your screen, buddy. And what we'll do, okay, let's say, go to the chat window. Okay, copy this function into the file.
Should I make a function call here itself, Naveen?
Is this that file?
No, I have
New file.
new file I have taken.
If you create a new file, okay, just try to say HOSUM. Or to test this one, what we'll do, you create another function called square, which is implementing a square.
Yeah, okay, Naveen. Here itself.
Yes, here itself. Good one. Okay, now in the next line, just say square root of 2. Okay, that's all. Write and quit. Func1 dot so just say scalar func1 dot scalar. Let's see if you're able to call the function directly.
It's not working, Naveen.
Cat it. Go back to the file and say print line of square 2, not just square 2. Okay, good. So now go back to that file. We'll try to say come here. Okay, try this one now. Add this one at the end and change the name of that square root to square.
Okay, okay.
Okay. And then put the semicolon.
There you are getting money.
I think there's a small thing that you're missing. Can you get that?
Much better.
Fixed data. Simple one, buddy. You're just missing a open bracket at the end. Print line.
Yeah.
Yeah, close bracket. What do you do? HO sum, you defined it again. Huh? It's not necessary. You have once it's you can remove the top HO sum. Pardon me. Okay, scalar function. Do a cat. Okay. Can you explain now why we are getting those results?
4 and 5. The first one is of it's a squaring of 2 going to 4.
Okay.
That 5.
This is a tough question, Shabas. Probably. Okay. Can you tell me what is that FN tint? That is the first argument. Can you explain?
It's like a lambda function.
Okay. What is it doing and what does that say? What is f there?
F is also a function.
Okay, what is that? What does the int tell you?
Here the values of square function, the value of square function is stored inside F2.
Pardon me?
2 is stored inside F, I mean.
Okay, so in other words, f colon int means f is a function, int is a argument. So that f can be any function which is taking integer as an argument. What does the right hand side int tell you?
Right hand side int.
That is the return.
Return.
Any function, yeah. So the any function which will take integer as an input and output an integer, you can pass it to HO sum. Catching it, Shavas.
Oh, yes, sorry.
That's what is higher order function. And let's say now try to add a function called ID in that file, which will take an argument and return the argument. Oops. Quit it. Don't write it. Just say Q exclamation. A function ID which will take an argument and return the argument. Pardon me.
This should be empty, Naveen.
No, if that is empty, nothing will be returned.
What should I pass inside?
We want the arguments to be returned. While using
I can use println.
no, not print line. Why are you using star args?
Star it can be like n number of arguments.
Okay, just say args there.
Okay.
And just return args. If you want to return args, how do you do that? Pardon me. Any idea? Just say args. Okay. So now add another line just like HO sum of square. pass the ID function to the HOSUM.
At the end, I should write this ID, or else in between I can.
Show square, pass in the ID. Okay. Good. Okay. So why are you passing two arguments to it? The 1 and 2?
Instead of square, you told me to pass ID.
Yeah, ID is okay. Why are you passing the right hand side two arguments?
Okay.
Why are you passing 1 and 2, Shabas?
Here A and B are
As simple as that.
defined, so that's why.
Good. Okay, right. Also add another function which is Q, which will do the Q.
Same arguments I need to return.
Q, not Q. CUB.
Okay.
Hmm.
Naveen,
Yeah.
can I add all these arguments inside HOSUM, like square, ID, cube? Can I pass all those arguments at a time once?
At a time. Okay, I'm not understanding your question.
I mean, like square 1, 2 and ID and cube.
Okay, write it. Let me see what you're saying.
Was trying to tell you like this.
No. You cannot pass square, cube, and ID like that. Because if you look at HOSUM, it is taking the first argument is the function.
Yes.
The second and the third arguments are integers. So if you're passing 3 functions, then it will not allow it. So you can pass any one function there. Okay, you can run it. So what is it you're getting when you say HOSUM of cube? 2, 3? 35, okay.
30.
Let's see what else I have here. Cube, sum squares, okay. Square. Sum squares, I wrote a function, some P2, okay. So function, okay. Else f of a. Okay, let's try this one. And f of a. F of a sum of, say, ID. We just did that. Some cubes. Multiply. Okay, let's try this one.
Yeah, Naveen, how we are getting 35 here?
What did you pass? You passed 2 and 3, right?
Yes.
What is 2 cube?
2 cube. No, 3 cube.
For HOSUM, what did you pass?
HOSUM 2, 3.
So what is 2 cube?
2 cube is 8.
3 cube?
27.
How do you get 35?
Okay, 27 plus 8.
True. That's what the HOSUM is doing.
Okay, ma'am.
Catching it?
Yes, ma'am.
So come back here. Okay, let's see what we have here. Just make a note. Say, okay, here's that. Okay, go ahead and paste these 2 things also into the file. Pardon me.
Naveen?
Please.
Naveen?
Yeah.
At the line println it was some cube of 2 cube comma 2 comma 3. After execution of this line, what happens? It cubes the 2 comma 3 and then pass those to h for sum. What operation would be done in h for sum?
HO sum cube 2, 3. Yeah?
Yeah.
Cube is a function we are passing to the function. Okay, and we passed in 2 and 3 as the additional arguments, right? So the first if condition will be false, it will go into the else block. Are you understanding? Let me take a screenshot of this. One moment, let me explain this. Hold on 1 second, don't change that, Shabas. This here. So, sharing my screen. So share the screen, say yes. Here we go. Okay. So let me come here. Choose this one. When you say HO sum cube 2, 3, cube is becoming this argument. Okay. And 2, 3. So here's the 2, here's the 3. That will be A and B. Next, what is happening is the condition is 2 greater than 3. It's a false, so it will not go there. So the first step when it enters the function, it comes to else and it says f of A. A is 2 and f is cube. So cube of 2 will be 8. This will become 8. Are you with me?
Yes, Naveen.
Lavanya. Okay, so that is the first step of the first step. Then it will do a plus. And the next step, what is happening is, choose this one, HO sum of, again, cube is becoming the function. A plus 1 will now be 2 plus 1. 2 plus 1 now is 3. And B is also 3. So when it comes here, is 3 greater than 3? No. So again it comes here. By the time it comes here now, this is 3. That is becoming f of 3, which is 3 of 3. So here we already had 8 is coming from the previous step. Now cube of 3 will become 27. Okay, plus, so 8 is coming from the previous step, 27 is coming from cube of 3. And now again this will get called, which is, let's say, back here. HO sum is going to get called. This time cube will be passed, 3 plus 1 will become 4. So this will become 4, this will become 3. And now when it comes here, 0 is returned because 4 is greater than 3. And since 4 is greater than 3, what will happen? 0 is written, that's it. So the final result is going to be 8 plus 27 plus 0. Catching it, Lavanya?
Yes, Naveen, got it. Thank you.
Okay. See, stop the share. Your screen, Shabas. Shivas, are you there?
Yes, Naveen. Naveen.
I'm here. Yeah. So let's see. Cat it, please. Multiply 2, multiply of 2, 3. Okay, now this is a slightly deep one. Let's say we used multiply here. Okay, let me see where I'm covering it. Two, 3. Want to explain, correct. So you passed in multi. Where's the result? Go back to the result. Oh, okay, you're adding it. Okay, sorry.
Yeah, Naveen.
So 2 times 3, we're getting 6, and 3 times 4, we're getting 12. And here, there's actually a little bit of currying going on. So that's what I'm trying to recall, what I'm trying to explain here. This is also a slightly advanced topic. It's syntactic sugar is what it is called, but okay. Okay, so short and sweet, 2 arguments are getting mapped to N1 and N2, okay?
Yes, Naveen.
Okay, you come back here. Try this one, please. Oops. Add this at the end. Back to chat window. Multiply 2 of 5, 4 is what you added. Multiply 2, 5, 4, okay. Let's see, what is this one? Come back here. Networking. point, print point. Okay, try running it. So you're getting it's okay. So that is how we define a class in Python. Also, if you recall, class is similar, but let's say here is another one. This is a slightly different way of defining a class, and add this at then. So come back here. So basically, if you look at cat, please. So case class, what we have written. Case class is another shortcut or a short way of writing a class is what it is, guys. That's all I'm trying to show you here. But I'll try to give you another example, which will be much more meaningful. Let me come back here. Okay, let's say okay, add this at the end. So, oh, so what do you think that is doing?
It's printing from 0 to 10, Naveen.
Okay. Go back to the file, copy paste the same for loop, but instead of a 0 to 10, give 0 until 10 in a new one. Copy paste again, the same thing below. Instead of 0 to 10, say 0 until 10.
Mhm. Should I write in words until? I mean,
Pardon me?
should I write in words?
Yeah, until UNTIL. Done. So where are you? Multitasking here, buddy. Okay, what is difference, buddy?
We are excluding 10 now. We are specified as until.
We are exclude as simple as that. And okay, next one. This I'll ignore it. Okay, now here is where a little bit of complexity is going to begin. Let me see if I have anything here for that. Say, come back here. Spark 6, higher order functions. Okay. Okay. Shabazz, take a short 10-minute break, please. We'll come back and continue.
Yeah, okay, Naveen.
Thank you, guys. Shebas, are you there?
Yes, Naveen.
Oh, can you make me the host, Shebas? I got signed off here. Oh, that's, I'm coming as signed, so let me rename myself. Atul. There you go. You have to click on more and say make host. Okay, thank you. And let's see, come back here, back to chat window. Let's see, okay, so now let's see, slowly increase the complexity here. Start with this one. Okay, try to execute this one. Get into the scalar. I'm sorry, I mean, get into the scalar shell, not the file. Oops.
Yeah, Naveen.
Okay, 29. Okay. So what kind of object do you think it is, Shabas?
Tuple object, Naveen.
It's a tuple object. More precisely, it's a range object is what it is. Here is the next one. Try it. You don't need to do print line. What do you think it is doing?
Every third element is not every third element. Naveen.
Every? You can forget about, you can ignore the too many decimals coming in between, but other than that,
From 1 to 9, decimal format, Naveen. Printing.
so in other words, more precisely, 1 to 9, it's generating 9 numbers. And what map is doing, it's something like a do. Or in other words, behind the scenes map is nothing but a for loop. It is taking each number. So on the left-hand side, we have a tray of 9 cups. Now it's taking each cup, which is indicated by underscore. If you're noticing, it says 0.1 multiplied by underscore. That underscore is indicating it is picking up each cup. When it picks up 1 cup from the tray, that is by default how Scala is indicating that it is a picked up item or it is a cup. And then what is it? It multiplies it, puts it into a new tray, and then it picks up the next cup that becomes the new underscore, or the underscore becomes that one. Catching it, Shivas.
Yes, Naveen.
Okay, let's say try this one.
Star times of 1, star times of 2, star times of 3. It's picking up 1 from 1 to 9. The stars are getting incremented.
Why are stars getting incremented?
Star times of 1. Your underscore means it's picking up 1. Star into 1, it's putting 1 star. Next,
In other words, more precisely, when you multiply a number with a string, the string is getting printed that many times. Here, the string is this. Catching it?
yes, ma'am.
Okay. Let's see. Here's a, okay, this might be it. May not be. Okay, try this one.
Uh, in every new line, it's printing Naveen. It's incrementing and printing in next line, new line.
As simple as that. So in other words, when you see map, we need to visualize it is creating a new tray. Oops. Then the tray is becoming the input to the for each. The for each is nothing but the for. And what is happening? Oops. Again, the for each print line underscore. If you notice underscore, what is happening is it is taking each string and it is print line. Print line is printing in a separate line. Everybody catching it, guys? Quick yes, please. Okay. And let's say try this one. Print. Okay. Say here is another one. Okay, try this one. Okay, so if you notice, if you just say print, it's just printing in a single line. Print line is printing in multiple lines. Okay. Now let's say if you can catch this one. Here's the next one. Try this one, please. Oops. So come here. What do you think is happening, Shivas?
Here, it's like an even number. Even numbers, finding out even numbers. Suppose one module to the remainder is not equal to 0, then it's printing in next in here vector of printing in new line.
So in other words, it's only printing the even numbers. So what do you think filter is doing?
There is
No, it's just filtering, as simple as that. It's just checking and seeing if a number underscore means each cup, each item, it is divisible by 2 or not. If it's divisible by 2, then you have a 0 remainder, right?
yes.
Simple as that. Okay. So you come here. Okay. So here's a now a tough one. Let's see if this works here. Okay, try this one. Shit. Okay. So tough one, Shivas. Can you try to explain what is going on?
First one is multiplied with 1, next one is multiplied with 2, next 1 into 3, 1 into 4. Afterwards, the remaining next item comes in place of underscore 2, 2 into 1. So it's getting like factorial now, 4 into 3 into 2.
Okay. Let me share my screen here. Okay, good one. So reduce left, we need to get a feel of it. Say come here, taking a snap. Move this here. Say back here, snap it, discard it. Put this here. Back to zone, say share, say yes, use the sketch. Okay, so 1 to 4, just visualize. This 1, is it 2, is it 3, is it 4, it's a 3. When you say reduce left, what's happening is it starts with a 1. It will take 1, it will put it here. Okay, so in other words, 1 is becoming underscore 1 times 1. That is 1. So put it here. And we have 2. Now, now what happens is, or more precisely, reduce left means, let's come back to 1. 1 is taken here. It becomes this underscore. It puts it to the left. The first time there is nothing, so 1 is there. Next, it picks up 2, puts it here, and then 2 times 1 becomes 2. No problem there. Then here comes 3. When 3 is taken, that means 3 times 2. So 3 times 2 is going to become a 6. So on the left hand side, you have 6. That is what left is. Reduce left is what they're doing. Then we have 4. So 4 is taken. It puts that becomes underscore. So it goes there. So now 4 times 6 is becoming 24. That is how it is one way how you can visualize that one. Catching it, Shivas? Everybody else catching it, guys? So in other words, something you guys need to be familiar is reduce left. That left, what do they mean by left is something we need to keep in mind. Okay, let me come back here. Stop the share. And let's see the next one. Okay, 1 to 9. Okay, let's try this one. Because, okay, try this one. So it should be pretty self-explanatory, but let's see. Okay, try this one. So what do you think that is doing, Shivas?
As per the length of the word, the sorting is done.
Good. So what do you think split is doing?
Split is splitting the statement. Mary had a little
And
into
what
a
happens?
tuple.
What happens when you split?
Separated. They are separated with comma.
Good answer. And explain sort with there.
Sort with.
Okay, underscore is each item. So first it picks up Mary.
Mary.
And Mary dot length will be 4. Then it picks up had. So now Mary dot length will be on the left hand side, visualize. Had dot length will be on the right hand side. So that is 4 is less than 3 is a false. So in other words, whichever is less between Mary and had, it is going to sort. So had will come on the left hand side and Mary will go on the right hand side. Are you able to visualize that?
Yes, Naveen.
Yeah. What about others, guys? Are you able to get it? Not showing the picture here, but Mary and had. How about Lavanya, Niharika, Pratyusha? Okay. Okay, so it continues. See. Okay, let's see. So to understand that, here is maybe just execute up to split and don't execute the right hand side part of it. Bring up that one and just execute till split. Okay, then you can, okay, now say, okay, now let me send you this one. Try this one. You pasted it 2 times, I think. Oops. Okay. Instant. Here we go. Okay, guys. So when you do a split, we are getting an array. That array is becoming input to the sort with. So A is an array. So in other words, the output of one step is becoming the input to another step. Sorry guys, I'm having some power cut issue here. Are you there? Can you give me a quick yes?
Yes, sir.
Okay. That is again what is referred also as pipelining. And let's see, come back here. Okay. Okay, so now we have to get into the Spark code. Sequence, parallelize, group by key. So I'm going to keep this reduced left. Okay. We may need to get into Spark. So exit out of the scalar shell. And just type in Spark -shell. Pardon me. And let's see what is the, just type in SC, enter. It's going to be the Spark context. Then type in Spark, small letters. Okay. Okay. So we have two objects, Spark context and Spark. But let's see what we have here. Okay, let's start with this one, which is, I come here, put it like this. Okay. Pasting it. Okay, try this one.
There is a delay, Naveen. I'm not able to.
Oh, it's probably loud. Okay, so now here is the next one. I've already sent it. I think, okay, here we go. So I come here. Have you? Okay, so here what we have is numbers is going to be an RDD object. It is like in the world of Spark object. Spark is again like Hadoop, which is a big data word. If you recall Hadoop, in Hadoop we store big data and we process the big data. At the time of processing the big data, MapReduce uses the hard drive, whereas Spark, that's where it comes in, and it uses the RAM instead of hard drive at the time of processing, guys. Okay. So when we say sc.parallelize, the array here, it is a small object, but in real world, when we say parallelize, we give it big data files. The big data files can be multi-terabyte files, which means they can be very, very huge files. They can be as simple, a small object as a array like this, which has just 4 cups in the tray, or it could be a file which is sitting on hundreds or thousands of computers. What is the magic of Hadoop and Spark? They make it look like one object. In other words, when the data is sitting on multiple computers, if you recall, it is very complex to work with them. It is very complex, but that's where the Hadoop and the Spark come. And they say you treat it like it is one object. You don't treat it like it is multiple objects, or it is like data sitting on multiple objects. So here in the world of Spark, the numbers, when you say c.parallelize, it is converting an array, which is a scalar object or a normal object, to a big data object, a big data set. When we say parallelize, we are converting it to a big data object. It is called resilient distributed data set. Now imagine, for the sake of simplicity, if this file, if this object was very, very big, in other words, let's say it was sitting on 10 computers. If this array was very, very big, and let's say one computer goes down, then Spark will automatically take care of bringing that object on another computer. This is nothing but fault tolerance. We have looked at it multiple times, discussed about it multiple times in the previous topics and things like that, guys. Okay, what is that? That is what is special about the Spark object. What is a Spark object? Spark object is a big data object. What is a big data object? A big data set. What is a big data set? It is called RDD. Spark calls it as an RDD. Our friendly mantra is going to be Spark object. Our technical mantra is it is a resilient distributed data set. Resilient means if it goes down, Spark is taking care of bringing it. You don't write code. Distributed means it is sitting. It can sit on 1, 10, 100 or 1,000 computers. It is distributed across multiple computers. It is a distributed data. That is what is distributed data set. Everybody with me, guys? Quick explains. So one more time, we go back to the big data thinking here. We try to apply some of the Hadoop concepts and things like that. Once you say parallelize, for now, we'll say it's becoming a Spark object, means Spark is going to track it. If this object, if we were to work on a cluster of computers, then Spark will take special care of this one. Normal objects, if your computer goes down, they don't come up automatically. Whereas Spark is something where if your computer goes down, if the data on this, if this computer goes down, Spark is automatically bringing up in another server in the cluster. That's what Spark does. That's what is big data and fault tolerance is about, guys. Okay, so now numbers is a Spark object. Parallelize is what is converting. So just type in numbers and press enter. Okay, so if you notice, guys, what is special about Spark object is behind the scenes, Spark maintains, for every Spark object, it maintains what is called a directed acyclic graph. It is nothing but it is called the architectural plan of that object. For normal objects, there is no architectural plan. When you create a Python object or a Scala object, there is nothing. When you say create object, it will create. Whereas here it is kind of a lazy initialization. It will not immediately create it. It will wait until until it is really needed. That is what is lazy initialization. So when you, in a Scala world or in a Python world, if we had an array, if we created an array which we called as nums, if you assigned it, the moment you say nums, it will print it. Whereas in Spark world, notice it is not printing it. It is giving you some kind of a parallel collection, RDD. What is this one? This is an architectural plan. For more complex objects, it will look more complex. We'll try to get a feel of it in the coming up days. But now what we do, say nums.collect. Type in nums.collect. Press enter. Okay, notice, so I think, so this is where the MapReduce is at work, behind the scenes. Systems. Still running.
It's taking a lot of time, Naveen. Should I stop it? Naveen?
Oh, sorry, buddy. I was on mute. I was actually talking. So don't stop it. We need to look at the output of this one. I'll also try to tell the lab guys to look into why it is so slow. But more precisely, in the world of big data, the data that we are processing is very small. Notice that is output. What it is doing is just giving us output, which is a very small object, but the amount of time it has taken is very much is what is the problem. So kind of in the world of big data, that the latency is generally acceptable because we generally work on very huge amounts of data. When we do the development, we'll take a small sample file, we'll do the development, and then when we run it, we'll give it an hour, maybe 2 hours, maybe more than that, multiple hours. Some jobs and things like that will take multiple hours, and based on their budget, they will increase the number of servers and things like that, guys. All those things you don't need to worry, but just I'm kind of getting you familiar with that. Everybody with me, guys? So quick yes, please. Okay, so let's see, come back here. Okay, now let's see to debug stream. Okay, try this one. I don't know, this is probably an outdated one, but let's say, here's the next step. Try this one. Okay, so to debug string is again just referred as an architectural plan. Okay, let's say the next one. Collect is done. So what do you think is collect, Shivas? What do you think collect is doing?
It's like collecting packages.
Okay,
Yeah.
collect is print.
Okay.
Okay, try this one.
Should I print it, Naveen? Where's dot collect?
Yes. Okay. So what do you think this function is doing, Shivas?
Where of a number? Where's When it's taking more time.
That's what I'm also thinking, buddy. Got a bunch of stuff in these things. Still in stage 2. Okay. Don't.
Naveen, Lokesh has got the output, Naveen. He messaged me.
It's got the output. Okay. If he gets it, you should also get it, buddy.
Once confirm with others, Naveen.
Anybody
Yeah.
Anybody else running Spark, guys? Other than Lokesh, I think Lokesh is one of them. Anybody else running Spark? Did you get it right away, Lokesh, or did it also take some time for you? Now, I mean, did it take time? It's running fast for you? It runs fast, I see. Okay, 1 minute. Then Lokesh, why don't you share your screen, buddy? We'll try it on yours. And you try to do a Control-C or Control-D on this one. Shabas. You can stop the share, Shabas. What is that? No, we have just run this map function, right? To debug string map is okay. Oh, okay, you didn't run it. Squares.collect. You're in Spark shell, right, Lokesh?
Yes, Navin. It
Oh.
is.
Okay, scroll down. Okay, then you is that what is sent? Just type in squares.collect again. Okay, it looks like it is running now. Squares.collect. Okay, I think it is going to take time for you also. Oh, Lokesh, did you do a Control-C?
Yes, Navin. To exit.
Okay. It's part of cancellation of folders. Okay, just do a Control-D, maybe Control-Z. Okay. So get back into Spark Shell again. And let's say, rerun the 2 or 3 lines one more time, just for sake of discipline. Okay, just send a message to Lakshmi, guys. Hopefully, the lab guys will look into this one. But this is, I'm just wondering. Squares connect. Still have a sequence object. Scroll down. Okay. Lokesh, can you try to the notebook there, right? Spark shell. Go back to our Azure Lokesh, Azure portal. Get back into no, not Cloudera. Get into Azure portal from the subscription. Yeah, Azure console lab. Yeah. And let's start. Let me know when that is ready. Okay. Yeah, click on Databricks, Azure Databricks. You see an icon, Azure Databricks. And let's say create a service. Create a new resource group. Can give your own, whatever is comfortable.
Can I go to networking now?
Workspace name. Yeah. Continue. This deploy Azure Workspace will secure no, deploy in your own version no. Click on next. Right. I think you can say review and create. Validating. Okay, create. Let's give it a moment. If this works, we'll Try to do this tomorrow. Lokesh, just remember that one.
Okay, Navin.
Still in progress.
So
So say launch workspace. Okay, and click on new notebook. Wait 1 second. Escape it. In the default language, see, select scalar and now give some name. Let's say L1 or Lokesh, whatever that is, something like that. That's a Lokesh one, yeah. And select a cluster. Click on create. I think this is where we did not create a cluster last time, so I think we may need to create a cluster. Okay, now that is scalar. Okay, create a cluster.
can I create it?
Yeah. Okay. Rest of you guys can sign up for today, guys. I'll let just Lokesh can hang in here for a few minutes and we'll test this and we'll continue from here tomorrow. Please review some concepts, because tomorrow I'll be asking again a few evaluation questions and assessment questions. So please try to review a few questions from our Azure questions and also from a little bit from Scala, guys. Everybody okay with that? Please feel free to sign off. Thank you. Let me know when it is ready. Even this is taking time.
Yes, it's created now.
Okay. Okay, now, yeah, click on notebooks. Are you there, Lokesh?
Yes, Naveen.
Okay. Oh, I'm having a little power cut here. One moment, please. Detach. Okay, we don't have any existing notebooks, so try to create a new notebook. Let's say, yeah, go on the left-hand side. And they should be, you should say create. Click on create. Or yeah, notebook. And select Scala. And now just give something like Lokesh 1 or Lokesh 2.
Creating notebook, an item called Lokesh already exists. Okay.
Just give a different name. Okay, now if you go back to a chat window, just type in SC first, SC, shifter. Make sure the Spark context object and the Spark objects are there. Okay, type in Spark, small letters. Okay, so if you go back to the chat window, where were we? Numbers, I think we need where you have the numbers. Say val numbers equal to sc dot parallelize array of 1, 2, 3, 4. Start there. Numbers equal to sc dot parallelize array of 1, 2, 3, 4.
I need to do parallelly.
Numbers dot to string, or just say numbers dot collect. It comes up quick, right? Okay, what we'll do tomorrow, we'll continue from here. Just remember this one, we went into the Azure console lab and we'll continue from here, Lokesh, rather than using our own cloud. Okay.
Okay, Naveen.
Okay. So you can sign off, buddy. Rest of you, if you're also there, you can sign off, guys. We'll continue the journey from tomorrow and go from there. You guys take care, stay safe, and keep learning. Stay safe. Okay. Thank you. Bye for now.